Hello, everyone. Welcome once more to Med-X-Deliverable. Today, we are presenting our work for Sprint 3. If you have looked at our previous presentations, you might recall that my team decided to create the Med-X AI product, which is a common thorax disease detector. Today, we will cover a recap of who we are and the project we chose. It includes member names, roles and responsibilities, improvements, project description, team working agreement, and personas. Followed by the project overview, which covers the MVP, languages and tools, algorithms, diagrams, and a Sprint 2 recap. Next, we will look at the backlogs, including product backlog, Sprint 3 backlog, test cases, story completion. Then we will move on to the team metrics, including team velocity, burn down charts, and the retrospective. And lastly, we'll showcase the improved product that we have been working on tremendously on adding features. In this section, we will look at Sprint 4 stories, application screenshots, API, and the live application demo. We have 8 members on our team. We continue to think of ourselves as self-organizing, cross-functioning, passionate, and hardworking. Our team members are Ronaldo.S as a Scrum Master and developer, myself, Marla Capistran, as team leader and database administrator, Filippo Zoloco as a developer, followed by Christopher Ospina, another developer, Anthony Munoz, quality assurance tester and developer, Liana Machado as a developer, Raul Nayanegali, a developer, and then Prithvi Raimanya as the developer and designer. We have all committed our time to this project and are so proud of how it is turning out, and everyone has played a crucial role in its development. After each print, Professor Wong gives us insightful feedback to improve our presentation and project. The improvements we have made for Sprint 3 are change the product backlog placement, rename user stories as product backlog, provide user story IDs, include a test case ID, indicate a pass-fail ratio of test cases, use story points for burn down charts instead of hours, and incorporate dot voting during the retrospective. You will notice a yellow star is placed on slides where an improvement was made. The problem today is that currently X-ray machines are widely available. However, clinical chest X-ray images can be challenging to read and diagnose. Furthermore, X-rays are not a priority for radiologists, as they tend to focus more on CT images and MRIs. CT scans are both harmful and expensive, in addition to time-consuming. And so our project, the Thorax Disease Detector, is a web app that has a highly trained deep learning model that classifies X-ray images, reducing the need for radiologists to examine them. It is intended for medical professionals and patients who upload X-ray chest images. It uses a deep neural network model that will detect common health issues. Rather than having to wait for a radiologist to examine the X-ray images that are not a priority to them, our application will reduce the time it takes for a patient to receive their diagnosis using AI. Some of the benefits from utilizing our application are a faster physician response rate. It is cost-effective, reducing the need to hire more professionals. Its use of AI, which reduces human errors and efforts. It partially automates the chest X-ray review process. And lastly, it improves physician workflow. The team working agreement was created during Sprint 1 to lay out expectations in order for the team to have a smooth and successful completion of the project. We commit to being transparent, accountable, being proactive and taking initiatives in tasks where a member's skill is capable, and above all else, prioritizing the success of the project. This document outlines the team's communication, participation, meetings, and respect, which ensures the success of the project and each team member. And now Anthony will take it from here.
Thank you. So, as a patient, you rely on medical professionals. You get checkups, health advice, and recommendations for procedures such as x rays when they're deemed necessary. However, people are busy with their daily lives trying to balance work and family. So, it's hard to schedule appointments, not to mention the follow up visits that may be required. The time taken to get results, depending on the procedure, can be a challenge in itself because it might take a long time. So you manage to make your follow up, you sit down with the doctor, and can still come out of that consultation with questions. So, using our chest x ray AI solution, patients will be able to get their results faster. They'd be able to review the results on a web page that's also easy to navigate. And lastly, a patient could see a doctor's comments about the result right away, allowing a patient to understand without having to schedule a follow-up for another in-person visit if that's not deemed necessary. Next slide, please. Mhm. So currently, healthcare facilities are facing unemployment issues and are in need of modern equipment. So, due to budget cuts and the rising cost of medical school and the debt that comes with it, not that many people want to specialize in radiology and wait till they're around 30 to start their careers. This leads to medical clinics suffering from a lack of applicants. In addition, the current number of radiologists isn't enough to train recent medical school graduates and accommodate the growing volume of patients. So these challenges are the root cause of burnout and long shifts, which leads radiologists to think about whether they want to stay in the profession. And the nature of the job requires radiologists to work with sensitive cases such as cancer, which directly impacts their ability to tend to all patients equally. So, using our thorax disease detector, we can alleviate that workload by automating the detection of known chest conditions. This would allow radiologists to concentrate on their more complicated cases, improving their overall workflow. Next slide. Right. So doctors have a large volume of patients with a limited time for consultations. So doctors sit with their patients, they explain to them their diagnoses, but patients can still leave with questions that they might look for answers online, which could lead to greater confusion and anxiety about what they've talked about with their medical professional. So our chest X-ray AI solution allows for a doctor to communicate with the patient by leaving comments about their diagnosis that explains the results clearly. This would also help build a strong relationship between the patient and doctor as well. Next slide. So we started our product design by collecting ideas from each of our teammates. We took everyone's designs as shown on the screen and picked the parts from each design that we liked. Then we discussed stuff such as color palette and agreed on a final product design. Next, please. So this is what we imagine our final product would look like. There'll be features such as being able to upload the x-ray, getting the results that come with a description of what it is, along with the doctor's comments underneath. You can also see that there's the x-ray ID, a progress bar that lets you know when your image has been reviewed by the doctor and radiologist, and an option to download the report for your records. Next, please. So we used Figma to visualize our MVP design. So as you can see on the right side photo, there's an option to either browse and pick a file, or you can just drag and drop an X-ray image. On the left side, you can see after uploading the X-ray, this is the result that we expect from our MVP. We have been able to achieve this and exceeded this MVP expectation, which will be shown later in the presentation. Thank you. And now I'll be passing on to Rahul.
Hey, thanks, Anthony. So, good evening, everybody. So, today we are going to dive deep into the cutting edge technologies powering our Med-X. So, at the core of this application lies a powerful combination of programming languages, frameworks, algorithms, databases, tools. So, all of these are working together seamlessly to deliver an accurate and efficient medical diagnostics. So before we delve into the specifics, let's take a moment to highlight the technologies upon which Med-X is built. So programming languages and frameworks first. So these are our building blocks that enable us to create dynamic and responsive user interfaces as well as robust backend systems. So moving on to algorithms. So at the heart of the Med-X lies a sophisticated deep learning algorithm that leverages the power of AI to analyze medical images with accuracy. So database. For secure and efficient data storage is crucial for our application. And Firebase enables us to manage and retrieve patient information and medical records seamlessly. So the lastly, it's tools. So where to streamline our development process and ensure seamless collaboration, we have selected a suite of powerful tools that enhance our productivity and workflow. So let's move on to programming languages. So here the frameworks and the programming languages that power our Med-X. So we have chosen powerful combination of HTML, CSS, JavaScript, React, Node.js, Tailwind CSS. So these are the front end frameworks that which our Med-X leverages and to create dynamic UI. So moving on to backend. So we have used Python's micro framework called Flask, so which is used to render chest X-ray images whose findings on the UI by calling the trained model. So moving on to database. So we have integrated Firebase for secure image storage and API access. So Firebase is used to store the uploaded images in a bucket, and in turn, it provides an endpoint URL we can use to call the API with that URL. So for tools, for efficient, efficient collaboration and streamlined workflows are essential for any project, right? So therefore, we have meticulously selected a suite of tools to optimize our development process. So Figma facilitates design collaboration, enables seamless contributions to overall development process. Whereas VS Code serves as a primary coordinator, providing a robust environment for coding tasks. And GitHub is a remote version control for collaborative development. And Docker simplifies deployment across various platforms, which streamlines the deployment process. So Insomnia is a tool which we use to test our API. Next slide. So now let's dive deeper into the intricate details of a deep learning algorithm. Our model integrates various layers with each with a specific role. So we have convolution layers, which are like filters that help us detect important patterns in the X-ray images. This could be patterns like, where some kind of abnormalities or any type of conditions. Sorry. We also incorporated batch normalization, which ensures stability and accelerates the training process. And dropout is another essential component, strategically dropping out some neurons during training to prevent model from becoming too reliant on specific features, mostly overfitting. Regularization plays a crucial role in controlling the complexity of a model. It helps prevent it from becoming too intricate, which could lead to poor generalization on unseen data. To optimize the training process, we have used ADAM, which is a learning rate optimization algorithm that adjusts the learning rates for each parameter based on each epoch. So to make our model even more robust, right, in for extensive training, so we have used around 200K chest X-ray images from Chexpert data set, which is given from Stanford Hospital. So this vast amount of data ensures that the model has learned diverse patterns and can provide reliable diagnostic insights. So with this combination of technologies, Med-X aims to enhance medical diagnostics, offering accurate and efficient solutions to improve patient care. So I'm passing on to Preet. Thank you.
Thank you, Rahul. Thank you for the great explanation about the technologies. Now we're going to understand how our app is working through some basic diagrams. And the first diagram is our context diagram where you can get the gist of our application. So here you can understand that Med-X is our tool which does the magic and has the code for getting the relevant result from the X-ray images. So here we have three entities, which are doctor, radiologist, and patient. They have the ability to upload the image, and as soon as the Med-X does its job, they can download and receive their image, receive the report in that sense. Next, we are going ahead with the class diagram. Here we can understand how our database design has been came up together. So we have four tables, which are patient table, medical professional table, X-ray table, and hospital. Each of them has their own details. Patient has details such as name, uh, number, birth date, whichever requirement for a report to be generated. And all of such has a medical professional, and so has a hospital. All of those are linked together towards the X-ray table, where the report has been generated. Going next, we are like. So here we can understand all the entities and how they are tied up with each other. So medical professional works at a hospital, and hospital is owning the software, which also has ultimately owning the X-ray. Patient can access the reports from our software, which have been used by an hospital. These are all the fields which come in action in this table. Moving next. So here we will understand the architecture of our application. We started with the front end, and React is the application where we use the front end for a good UI using Tailwind CSS. The patient, the user, would be looking at the UI from the front end part, which then where they upload the report data, and further it goes to image analysis into our through our Flask server, going into a neural network model, which will then get a result from that X-ray and will pass it to the Firebase. Then our application would receive the same data from the Firebase and provide it back to the patient or the user at through. And this whole application is Let's understand the sequence of how it's going to work. So user will first upload the X-ray. This X-ray from the website is carry forwarded to Firebase storage. Inside the storage, the location, the URL will be generated and then will be carry forwarded to the Med-X tool. Med-X tool with that UI will generate the result and send it back to the front end. After that, it will be stored into a report system based and storage. We will further forward it to the website back again, and user will be able to see that report and download it. Right. Now we understand how the states are being updated within our application. The first user logs in, uploads the data as an image. The image X-ray file will be then change its states to pending as it's soon getting uploaded to the storage. Once the image is accepted through our machine, it will be then classified into whether it's reviewed or not reviewed. If it's reviewed, it goes back to the doctor's, back to the patient's side, and then a user can view the report and move on. If it's classified or cannot find any abnormalities, it goes back as a report to the patient, and user can then see the report. And once done, they can log out. Going next. So let's go into back to the Sprint 2 and have a recap. So what we did in Sprint 2 is that we designed the UI for search bar. We created a image upload and submit Firebase function. As soon as that was done, we created a function for getting the medical term. We then also develop the loading page, which is required when such functions take time and which can be executed by async functions. For this to come into action, we needed a database which we created on our Firebase. Let's say if an image is not accepted, we created an alert message that whether the image can be accepted in the particular format or not. The neural network was created through TensorFlow and Keras, which we later on upgraded by using more detailed neural network and increasing our accuracy by 93%. Overall, we achieved 35 story points, which we promised in the sprint 2, and that resulted into our 100% completion of our story point. That's it from my side. Carrying forward to Christopher for further details. Thank you.
Thank you, Preet. And as you can see here, we've improved on our product backlog, and we had more test story points fulfilled by this sprint, such as doctor being able to add comments to X-ray results and patients being able to view whether a doctor has reviewed their own X-ray results so they could be more confident. Next slide, please. We've also added the functionality of doctors and patients downloading X-ray results through PDF format. And that way, patients can more quickly view their latest reports. By the next sprint, we plan to have access to all our report histories and be notified when there's a change to certain reports, as well as X-rays being explained in simpler terms for patient understanding. Next slide. In addition, we made sure that doctors and patients are now able to browse specific reports and records through the search bar functionality. And come next sprint, we plan to register distinct accounts so people could store their own personal data for security reasons. Now, here's Liana.
Thank you, Chris. So now we'll be moving on to the user stories. So based on each of the user stories, we described the acceptance criteria, which represent the conditions that must be satisfied for the user story or feature to be accepted. This was done by using the structure of being given a prediction when something happens, and then there was a result. For Sprint 2, these were the conditions that we met. If a videologist, doctor, or patient wants to upload an X-ray image through the image upload feature, when they open the Med-X-AI web app, click on the upload button and select an image file or drag and drop the image file. Then the application will store the image for processing. In this scenario, the criteria our web app satisfies is being able to store an image file for processing. Now moving on to more of the acceptance criteria, we see that the team had met last sprint for more acceptance criteria and user stories for the web app to provide a diagnosis or finding for the X-ray provided through the Med-X feature using AI. When a radiologist or doctor uploads an X-ray image, then the application will classify and provide a quick diagnosis, and then they will be able to access the result. For Sprint 3, we worked on the Doctor Notes feature, which provides a text box message section for each report to allow doctors to post comments for the patient to see. This is a form of communication between the doctor and patient for any extra information that would need to be mentioned. Another criteria we met this sprint is a reviewed status feature where a patient can view a status file reporting if a doctor has verified their X-ray result and updated the report when they click on any of the patient's reports. Also, the criteria of the web app providing a text description of the X-ray finding classified in a selected report will be satisfied during Sprint 4. Some other notable criteria we met during Sprint 3 are for Med-X AI to be able to download report files to the user's local system. We plan users to have a history of past reports available, which are stored in the cloud during the next sprint. Next, when the user logs into Med-X AI, then a dashboard page is displayed with the most recent X-ray results. Following that, a notification feature will be added during Sprint 4 with the criteria of alerting the user of a change made to their report. After that, we see more user stories, where in Sprint 3, the web app is able to access reports using multiple identifiers to filter, including an X-ray ID, report date, and status for the search feature to quickly locate specified reports. Furthermore, for the last sprint, users will have profiles where the criteria is for Med-X AI to store user credentials so that users, either a radiologist, doctor, or patient, can create their own account to securely access patient information. Now, along with the profile feature, the web app will be expected to have a login and logout system for medical professionals and patients. When opening the app, the user is then prompted to log into their account with their credentials and click the logout button to end their session. With the login and logout system, Med-X AI will be expected to create and store accounts where a medical or Med-X ID is used for physicians and a personal email is used for patient accounts. Lastly, the team expects to meet the profile criteria in Sprint 4, which includes allowing patients to update profile information and store their changes in the database when a user goes to their profile and clicks the edit button. Profile information includes their name, address, and phone number. All the conditions I have described must be satisfied for that user story or feature to be accepted and considered done. I'll be giving it back to Mala. Thank you.
All right, thank you, Leanna. So for Sprint 3, we worked on adding several features to our product. We provided a section for doctors to communicate with patients by leaving a comment on the report. We also provided a status indicator to let patients and doctors know whether or not a report has been reviewed. The two statuses are reviewing or reviewed. Next, we gave users an opportunity to download a report to their devices or print a physical copy of it. Then, we made the dashboard dynamic by displaying the most recent report for a patient or the most recent report to the database for the doctor. Lastly, we gave the UI of the search bar functionality by allowing patients and doctors to search reports by report ID, medical term, date, and status. All of these features counted for 33 story points in Sprint 3. As we worked on Sprint 3's backlog, we had to create some test cases to ensure that our application was running as intended. We aligned these test cases to user stories, which we have indicated with user story ID, as well as the feature being tested. We also designated a unique test ID number to keep track of all of the test cases. For example, when testing the search bar, we used an exact ID, partial ID, and invalid ID. All of these test cases passed. We also tested the search bar by typing the status, either reviewed or reviewing, and by entering a date. Again, all of these test cases passed. Another feature we tested was the download report. We tested to see if we were able to download and print the report. We successfully achieved both. Furthermore, we tested the doctor's note feature to see if the status of the report updated when a comment was typed. Even though the status changes from reviewing to reviewed when a comment is added, we notice that one can just click on the update report button without including a comment, and the report status changes to reviewed. Due to this test case, the pass-fail ratio of the test cases above for this sprint is 12 out of 13, or 92%. Ronaldo will take it from here now.
Thank you, Marla. Okay, so for the Sprint 3 story completion, as you can see here, we have all of the story points listed for Sprint 3, and all of those were completed as well. There are columns that show the estimation, user story ID, type of user, idea, purpose of that idea, feature, and the status. You will notice that there is a star on the user story ID, and this was added based on professor's feedback. At the bottom, the story points, the total story points for this sprint is 33. You get that by adding all of the estimation numbers from the estimation column. Next slide, please. Okay, so the team velocity for this sprint was 33 story points. Here, okay, so as you can see, we have two burn down charts, one for sprint 2 and one for sprint 3, with their ideal lines and the remaining actual lines as well. Okay, next one, please. Okay, so on this graph, we can see the average burn down chart from combined from sprint 2 and sprint 3. And you can see pretty much that like the graph has its upsides and downs, but we were able to have everything completed by the end, which is great. Okay, next one, please. Okay, so this is the completed and committed ratio graph. As you see, the story points completed for sprint 2 was 35 and sprint 3 was 33. These give us an average of 34 points within 100% completion. Okay, next one, please. Okay, so this is a screenshot of the retrospective board, and I will be going more into details on the next slides as well. Okay, so the retrospective shows three columns: what went well, which was listed as the most listed ideas for each column as well. So the four main points for this column was the team morale was good and no interpersonal conflict, the flexibility to move on our schedules around to prioritize the project, good team communication for resolving issues, and the sprint agenda was clear, organized, and is structured. Okay, so what needs to be improved? There's three things that were voted, and one is to plan out work time so it doesn't impact sleep or personal life, keeping up with story points to improve the burn down chart, create limited branches on the repo and maintaining those as well. And then moving on for action items, there were three mainly points as well. Evenly distribute the tasks to be completed daily. After two or three tasks are completed, come together as a team and showcase what has been worked on. And lastly, on the day of the collaboration, assist one or another with the troubleshooting. Okay, now for the sprint for workload, what needs to be sorry, okay, we have established a total story of 44 points projected for our next sprint, and you can see the there's a star listed at the bottom, which that was the column that was added based on professor feedback. And then there's total of 5 tasks for this table, and the total estimation points from these 5 tasks is 22. And the features from this table are one result description, and there's 2 versions of report history, one as a patient and one as a doctor. Three, there's 2 versions of notification, one as a patient and one as a doctor as well. For the next, there's 5 tasks, and the total estimation points for these 5 tasks is 15. And the features from these tables are, there's 3 versions of profiles, one as a patient, one as a doctor, and one as a radiologist. Yes, and then there's 2 logging in and logging out versions, one for the patient and one for the doctor. Okay, next one, please. Okay, and lastly, we have 3 tasks, and the estimation points for these 3 tasks are 7, and the features from these tables are 2. Two more versions of the logging in, logging out for the patient and doctor, and the patient's profile. If you add up all of the estimations points from the previous the table that was just mentioned, there will be a total of 13 tasks, and the total will come out to be 44 story points. Okay, next slide, please. Okay, so this is an example of a function that was added on the Med-X that JS file, which is the handle and predict function. So on a high level, this function takes an image URL as a parameter and sends a request to a local server endpoint, which is localhost 5001. And then while waiting to receive a response, it tracks and prints the prediction name and description. It also updates the components states, set finding, and set description with the prediction details. Lastly, it takes the user to a report page with the prediction data, and if an error occurs, the error is printed and sets the loading states to false. Okay, thank you, and now I'll pass it on to Filippo.
Hey, Ronaldo. The following is a series of screenshots of the application as it is in Sprint 3. Here we have a screenshot of the login page. A user can choose to log in as a patient or as a doctor. Next slide, please. Here we can see the dashboard page when we log in as a user. More specifically, the user is Angela Fernandez, and it's got the phone number below and a logout button to show that a user can choose to log out and log in as a different patient or doctor. Next slide, please. In this slide, we can appreciate the fact that our code intelligently accepts images of the format PNG and JPEG, and every time that we submit a format different from either one of those two, then the code will error out and show that that the wrong format has been uploaded. Here, we can see that an image has been uploaded and a user can choose to submit it. And in the Med-X page is updated with the results from the neural network, along with displaying a button of submitting the report, which will be submitted to the doctor, to the doctor's view. Next slide. Once the submission button's been clicked, the Med-X application will show an alert that says that report has been submitted, along with a report ID and the status of the report. In this case, the status is set to reviewing. That means that the doctor hasn't yet reviewed the report, and the same will be reflected in dashboard upon logging back in again as part of the record history. Next slide. We added a search function into the search bar that enables a user to look up a record either by ID, results, status, and date. As you can see from the snapshot to the left, upon entering the digits 00, we have a long list of records whose IDs begin with 00s. And next to it, we have a long list of all the findings, the statuses, and the dates when these reports were taken. And to the right, we have a record is displayed with report ID, the results from the neural network, and the status, along with the doctor's message, which is, of course, not yet there, as indicated by report status, is yet to be reviewed. Next slide. This is an example of a printout of the report of an X-ray scan with the condition and the explanation of the condition, along with the current status, which is set to reviewing, hospital name, doctor's comment, and to the right are all the users' details, including ID, name, date, email, and phone number. Next slide. To build our application, we used Firebase APIs, as Firebase turns out to be both a software as a service platform, but also a very convenient backend as a service. That is, all the backend services that we chose not to build ourselves were already available on Firebase, and upon importing the libraries, we found out that it was possible to upload all the images to a storage bucket that would then generate a Google API for us to manipulate the data in a second term in a later moment. And the Med-X function here will show that the dependencies ref, get, download URL, and upload bytes fetch a PNG or JPEG photo from the system and converts it into an internet-friendly data type, and then fetches the Google-generated API for our application to use later. Next slide, please. The Flask course combination proved to be instrumental in the building of our application. Flask allowed us to run continuous Python code as a framework, and the course library allowed us to expose the port that that fetches the URL from Firebase and analyzes it, pushing it to the neural network. Next slide, please. We chose Docker as part of our architecture, as it provides a containerized instance that allows us to run all the frameworks and their dependencies across platforms. And in Sprint 2, we were able to get the API responses and estimates of the analysis of the images and the terminal will report that we'll get a response back from the neural network in under 50 milliseconds. Upon importing a more advanced neural network generated, built by the researchers at the University of Stanford, we ran those tests and learned that the neural network, we would get responses from the neural network in slightly longer times, such as 135 milliseconds, or sometimes even 176 milliseconds. But we chose to not to discount quality over speed, and we were able to get classifications of X-rays with 93% accuracy in under 1 second still. Next slide, please. And here is a snapshot of what running the application in Docker is like. Needing 2 containers, someone could just click on the ports link and run the front end or back end, or test them both. And this is a video of our live application.
Today, the Med-X team will present a second live demo of the Med-X AI application, showcasing its new features. In our first video, we were able to upload an image and view the preliminary result. In this video, we will use the search bar, view the report status, add a doctor's comment, and print the report. As mentioned in the first video, the Thorax Disease Detector is a web app that has a highly trained deep learning model that classifies X-ray images. Let's begin. The login page will show an option to log in as a doctor or a patient. Depending on the type of user, the user will choose the correct login for themselves. We will be logging in as a patient. Later in the video, we will log in as a doctor. Once logged in, it will automatically take the user to the dashboard. This is where the last session of the report can be viewed. In this case, we are logged in as Angela Fernandez. We are now viewing her most recent report, which includes the finding, date, report ID, and doctor's comment. In this case, we can see that the report still needs to be reviewed by a doctor, and a doctor's comment needs to be added. The next step after our dashboard would be the Med-X tool. This allows a user to upload an X-ray chest image by dragging and dropping an image onto the Med-X tool, or by clicking on the Browse button to select the image. We went over this in video 1. For this video, we will use the Browse button to select an image. Once the image has been selected, the user must submit the image by clicking on the Submit button. Soon after, they will see the loading screen, which indicates the image is being analyzed by the neural network model, and within seconds, the result page will be displayed. Angela's diagnosis is atelectasis. We can also see a Submit button report. When we click on Submit Report button, a unique report ID is generated, and the report is submitted to the database and to the doctor's portal as well. As you can see, a message shows up displaying the result, the status of the report, and the unique ID. Once you click OK, you are redirected to the dashboard. This report was given a report ID of 12. Additionally, there is a review status bar showing reviewing, meaning that it must be validated by a doctor. In order for Angela to view her past reports, she can click on either the Report tab or use the search bar. We will be using the search bar. As you can see, an existing report is listed, showing the report ID, diagnosis, review status, and date. Angela might even want to look up her reports by date. In this case, she can type in the date of her report into the search bar. As you can see, She has multiple reports on April 3rd. Furthermore, Angela can use the search bar to look up reports reviewed and validated by doctors. When she types reviewed in the search bar, it lists all the reports that have been reviewed. When she types reviewing, it lists all the reports that need validation by a doctor. As a quick glance of all the reports she has submitted, Angela can click on the Report tab. The reports are shown as thumbnails with their respective report ID, diagnosis, and report status. When clicked on, you will see the report details. At this time, Angela may choose to print her preliminary report. However, it still needs to be validated by a doctor. In order to print the report, she will click on Print Report. And in the print window, one can see that the status of the report is reviewing, meaning that the report has been submitted to the database, but a doctor has not yet reviewed it. Consequently, a doctor's message is missing. Once a report has been reviewed, the report message will be displayed. And here is an example of a report that has been printed. We can see the ID number, the patient's name, the date, the medical term, the status. We will now log out as a patient. And we are redirected to the login screen. Now that we have viewed the user interface as a patient, we will see it again from the perspective of a doctor. This time, we will select the doctor. The dashboard looks almost identical to that of the patient. However, the doctor is viewing the most recent report updated to the database. The doctor sees the report ID, diagnosis, doctor's message section, as well as the review status bar. This report still needs validation. The doctor can also click on the Med-X-er, just like the patient, and upload an image. The report gallery for the doctor shows all the thumbnails with their respective report ID, diagnosis, and status for every patient. This can be daunting to sort through when trying to find a report for a specific patient. The search bar allows a doctor to search a report by ID, medical term, or date. The doctor can filter the reports by date, only viewing the report for a given date. In this example, the doctor is viewing the list of reports for April 4th. The doctor may also type in a medical term and view all of the reports with a specific diagnosis. In this case, we are viewing all the results with lung opacity. Furthermore, a doctor can use the unique report ID and type that in. Report 12 gives us atelectasis. And we can see that this report still needs reviewing. Lastly, a doctor can filter the reports by report status, distinguishing between reports that need validation versus reports that have been validated already. So those are the ones that have been validated, and we will see the ones that need validation now. A doctor can also add a comment. In order for a doctor to validate and provide a comment, the doctor needs to select a report. In this case, the doctor will click on the report that we have uploaded as a patient earlier in this video. Once the doctor is viewing the report, they may provide a comment. Please schedule a follow-up appointment. Before updating the report, and they would click update report. A pop-up message will be displayed indicating that the comment has been submitted. Once the doctor has validated and updated the report, they will automatically be taken to the dashboard, which is what we are seeing now. The doctor's message is now displayed. And additionally, the status of the report is now changed to reviewed. We will now quickly log in as a patient to show the doctor's comment and updated status on the patient portal. As you can see, report 12 now shows a doctor's message. Please schedule a follow-up appointment for report number 12, and the status has changed to reviewed. To build this current version of the MVP, it took our team 3 sprints. We continuously use Figma as a collaborative design tool. We update and improve the existing code in Visual Studio Code. We will continue adding more features in the next and final sprint, such as multiple user sessions, notifications, and user profile updates. This concludes the demo for the thorax disease detector. I hope you find this application valuable. Thank you.
Now we're going to cover the next steps of the development of Med-X AI. We're going to notify users when their status of their when their report statuses are updated. That is, every time that a doctor has reviewed their X-ray report, users will be receiving a notification on their end of the application and will be able to see those comments in their dashboard. We're going to create multiple user sessions. That is, we're going to enable multiple patients to log in, and as well as doctors, without interference between the accounts and in compliance with the standards of data privacy. We're going to provide friendly definitions of medical terms. We understand that not everyone needs to go to med school in order to understand their conditions. So we're going to explain in non-medical terms exactly what the patient conditions is. And we're going to create a sign-up page so that we can add as many users as possible and among doctors and patients. Here is a link to our updated wiki page on GitHub. Thank you so much for listening, and I hope you found this presentation valuable.